This is the Geometry Chapter 3 review, and we're just going to briefly just touch over the basis of the chapter. In the very first section, we talked about parallel lines and transversal lines, and the big thing that you know what parallel lines are. Transversal lines are lines that cross at least two other lines. But first we talked about skew lines. Skew lines are lines that do not intersect and are not coplanar. So they never cross, but they're not on the same plane. So skew lines in this illustration might be BH is skew with EF. So those two go together because these run up and down and these run this way at a different angle, so they never are going to cross. That one continues down, this one continues this way, and they're not on the same plane. If you wanted to pick another one, maybe CD and BH. Okay, so in other words, they're never going to cross even if they continue on, and they are not on the same plane. In other words, they're not on the same flat surface. A transversal line is a line that intersects two or more other lines in the same plane. So in this particular illustration, A is a transversal that crosses over both L and M. When you have a transversal, special angles are formed. So you have exterior angles, which would be angles on the outside of the two lines that are crossed over. So angle 1, angle 2, angle 8, and angle 7 would be exterior in this illustration. Interior would be 4, 3, 5, and angle 6. You also have what's called consecutive interior, which are lines that are inside, or angles that are inside that are on the same side as the transversal. So angle 3 and angle 6 are consecutive interior, and angle 4 and angle 5 are consecutive interior. Alternate exterior would be exterior angles that are on opposite sides of your transversal. So angle 2 and angle 8 are alternate exterior, and angle 1 and angle 7 are exterior. Alternate interior, same thing as this, but rather than being exterior, now they're interior. So angle 4 and angle 6, angle 3, and angle 5. Corresponding angles are angles that are on the same side of the line, so they would both be above the line, and they're also on the same side of the transversal. So examples might be 2 and 6, 3 and 7, 1 and 5, and angle 4 and angle 8. Okay, so like if you look at 2 and 6, they're both on the right side of the transversal, and they're both above the two lines that it crosses. Okay, then also on any of these illustrations, you're going to have linear pairs, which are lines that form a straight, they're angles that form a straight line with their opposite rays. So angle 1 and angle 2, angle 2 and angle 3, and there's all kinds of them. Angle 3 and angle 4, angle 4 and angle 1, angle 5 and 6, 6 and 7, 7 and 8, 8 and 5. Vertical pairs are angles that are formed by two intersecting lines. So angle 2 and angle 4 are vertical pairs. Angle 1 and angle 3 are vertical pairs. Angle 5 and angle 7 are vertical pairs. Angle 8 and angle 6 are vertical pairs. In section 3.2, we talked about angles and parallel lines because we know special things about those angles we just talked about. If I have two parallel lines, so these two lines have to be parallel, and there they have to be cut by a transversal. So on this one I would say M and N are parallel, and they're noticed to be parallel because they both have a triangle on them, and perhaps are cut by a transversal L. Well, I know corresponding angles would be congruent, and I think I drew these out. I did. So we're going to try and put those all together on one thing. Okay, so corresponding angles are congruent. So corresponding angles here, we would have angle 1 and angle 5. Now remember, they're only congruent if M and N are parallel. 4 and 8 would be congruent, which means they have the same measurement. Angle 2 and angle 6 would be congruent. And angle 3 and angle 7 would be congruent. So in other words, 1 and 5 have the same measurement, 4 and 8 have the same measurement, 2 and 6 have the same measurement, 3 and 7 have the same measurement. Alternate interior angles are congruent, so angle 4 is congruent to angle 6. And I could also say angle 3 is congruent to angle 5. Alternate exterior angles are congruent. Now remember, this is only if these two lines are parallel and they're cut by a transversal. So parallel, cut by a transversal. Alternate exterior, angle 1 would be congruent to angle 7. Angle 2 would be congruent to angle 8. Then I also know that consecutive interior angles are supplementary. Supplementary means they would add up to 180 degrees. So angle 3, the measurement of angle 3, plus the measurement of angle 6 would equal 180. The measurement of angle 4 plus the measurement of angle 5 would also equal 180. There's also what's called a perpendicular transversal theorem that says in a plane, if a line is perpendicular to one of two parallel lines, let's say we know these two lines are parallel, if it's perpendicular to one of them, then we know it's perpendicular to the other one. So here's an example problem done with this stuff. We know angle 5 is 2x minus 10. We know angle 6 is going to be y minus 25. And I know that angle 7 would be x plus 15. I can sit here, I know these two would be corresponding angles, so they are going to be congruent because these two lines are perpendicular. So I can say 2x minus 10 equals x plus 15. I'm going to subtract the x and get an x. I'm going to add the 10 and I'm going to get a 25. So I quickly find out x equals 25. If I plugged it back in here, I know that I have this angle right here would be 40 degrees. Now that's important because I know that these two are alternate exterior. If I look at these two as being parallel and this being the transversal, then I can say 40 is equal to y minus 25. I'm going to add the 25 and I'm going to find out that y is equal to 65. So I use all the information that I know about parallel lines being cut by transversals to be able to figure out values of x and y. Section 3.3, how to do with slopes of a line. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You probably have that in your calculator at this point, but you should be able to find the slope of the line given a graph or a set of points. So either one, you should be able to count on the graph between 2 points, rise over run, or you should be able to use your formula if they gave you 2 points. You should be able to graph a line given a point and a slope. These are all things you're going to practice on your homework doing. Remember that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. All important information for this chapter. So now we're going to work on coming up with equations of a line for different scenarios. Remember, they might ask you for the slope-intercept form, which is y equals mx plus b, or they might ask for the point-slope form, which is y minus y sub 1 is equal to m times x minus x sub 1. If they do not specify which form, you're going to be doing this form. So you should be able to do this in each situation. Let's say they give you a slope is negative 1/2 and they give you a y-intercept of 6. Then if I'm putting it in slope-intercept form, I have y is equal to negative 1/2 x plus 6. Here's my slope, here's my y-intercept. That's all I would have to do. If I'm putting it in the other form, if I have a y-intercept, that tells me that my x value is 0 and my y value is 6. So then I just plug it in, y minus, and I put the y value there, is equal to negative 1/2 times x minus 0. So now that's in point slope. It's the same line, but this is in slope-intercept form and this is in point slope form. Let's say they give me a slope. Let's say the slope is equal to 2 and it goes through the point, I don't know, 4, negative 6. Now, again, you can do it in either form, okay, but if they don't tell you, they want it in slope-intercept, and y equals mx plus b. So first thing I'm going to do is I'm going to put my slope in. Then I'm going to plug in my x and y, so I have a negative 6 is equal to 2 times 4 plus b. Then I'm going to solve for the b, so I have negative 6 is equal to 8 plus b. I'm going to subtract the 8, get a negative 14 is equal to b. Then I'm going to plug back in the slope and the y-intercept, or the b. And I find out that that is the equation of the line in slope-intercept form. If I want to do it in point-slope form and then switch it to y-intercept, I can do that too. So I have y minus a negative 6 is equal to 2 times x minus 4. So I'm plugging in the slope and the x and the y. So I have y plus 6, and then I'll go ahead and do distributive property here because I'm going to put it in slope-intercept form. Minus 8, I'm going to subtract the 6 to get the y by itself. And you'll see that I get the same equation, just done 2 different ways. Then they might give you 2 points. So let's say we have negative 2, 4, and we might have, I don't know, 6, 8. Okay, the only thing that's different between this one and these two is I have to find my slope first. So I can either use the slope formula in my calculator or I can do it by hand. So I have 4 minus 8 over negative 2 minus 6. I get a negative 4 over a negative 8, which is going to give me a positive 1/2. So I have, and I'm just going to do it the left way, but you can do it the right way if you want. So I have y equals 1/2 times x plus b. Now I have to choose one of these to use. I'm going to choose this one because it doesn't have negatives. So I have 8 is equal to 1/2 of 6 plus b. So 8 equals 3 plus b. I'm going to subtract the 3, and I'm going to find out that b is equal to 5. I plug back in the slope. Remember, the slope was 1/2. And I plug in the y-intercept, or the b. So that's the equation of the line that goes through those 2 points. You also might have a situation where they give you 1 point and they give you an equation. So let's say we want the equation of the line that goes through 2, 4 and is perpendicular to y is equal to negative 1/2 x plus 5. The only thing I'm using that for is to find the slope. And if it's perpendicular, it means I need to use the opposite reciprocal slope. The slope here is negative 1/2. So the slope I need, I'm going to flip it. So it's going to become 2 over 1 and take the opposite sign. So it's going to be 2. Then I'm done with that equation. So I have y is equal to 2x plus b. Plug in my x and y. So 4 is equal to 2 times 2 plus b. So I have 4 is equal to 4 plus b. And I'm going to find out that b is equal to 0. So I have y is equal to 2x, because that's the slope I'm using, plus my y-intercept, or I could just write that since my y-intercept is 0. All right, section 3.5, you were proving that lines are parallel. Basically, if you can prove any of the following, you can prove that two lines are parallel. If the corresponding angles are congruent, the lines are parallel. If alternate exterior angles are congruent, the lines are parallel. If alternate interior angles are congruent, the lines are parallel. If corresponding angles are supplementary, the lines are parallel. If two lines are perpendicular to the same line, then those two lines are parallel. And if two lines have the same slope, then those lines are parallel. So if you can prove any of those, you can guarantee that two lines are parallel. So here's an example problem. They might say find x so that L is parallel to M. Okay, so if you look here, T is the transversal. These two would be corresponding angles. So to find x so that these two would be parallel, that would mean these two would have to be equal to each other. So I have 4x minus 6 is equal to 3x plus 6. I'm going to solve for my x, so I have x on one side. On the other side, I've got 12. So I find out that x would have to be equal to 12 for these two lines to be parallel, because that would mean, let's see, that would be 48, this would be 42, and this would be 42. Okay, this problem, these two are alternate exterior angles, because I'm trying to prove that these two lines are parallel. If I have two parallel lines cut by a transversal, then alternate exterior angles are going to be congruent. So I have 7x minus 4 equals 5x plus 18. So when I solve, I get a 2x here, and I'm going to add the 4 there, so that's going to be 22, and I'm going to find that x is equal to 11. So if x is equal to 11, these two lines would have to be parallel. All right, perpendicular in distance is section 3.6. The shortest distance from my point to a line is the line drawn from the point parallel, or not parallel, perpendicular to the line. So if I have this point up here and I want to draw it to line L, I need to draw a perpendicular line. The shortest distance between two lines is going to be the perpendicular line drawn between them. Obviously, you don't want to draw a line like that because that's not going to be the shortest distance. So it has to be perpendicular, and if these two are parallel, then it's actually perpendicular to both of them. So the last thing that we did in this particular chapter is we found the distance between two lines. We went through these steps. You graph the lines, you pick the y-intercept of one of them, you write the equation of the line that goes through that y-intercept and is perpendicular to that line, okay, the line that you got the y-intercept from. Find the intersection between the perpendicular line equation that you just found and the other line, the line that you didn't choose for a y-intercept, and then use the distance formula to find the length between the intersection and the y-intersection that you chose. Okay, so here's an example. First thing I'm going to do is I'm going to graph these, and I do encourage you to use different colors. 1, 2, 3, 4. I think it's easier to see that way. Then I'm going to go up 2 and to the right 1. So this is y is equal to 2x minus 4. And then this one, the y-intercept is 1, and I'll go up 2 and to the right 1. And that is going to be parallel to that. I'm going to put the equation next to it so that I can know what to put in my calculator. And now what I want to do is I want to pick one of these y-intercepts. I'm going to pick this one because that's got positive numbers. So this is the point 0, 1. And I'm going to draw a line that is perpendicular to the line that has that as a y-intercept. It's also perpendicular to the other line. So I want the equation of that green line. So I know I want the opposite reciprocal here. So the slope of that green line is going to be negative 1 over 2. And it's going to go through the point 0, 1. So I have y is equal to negative 1/2 x plus b, and then I plug in my x and y, so I have 1 is equal to negative 1/2 times 0 plus b, b equals 1. So the equation of the green line is y equals negative 1/2 x plus 1. Now I'm going to use my calculator to find that point of intersection. So I'm going to put the green equation in. So I have negative 0.5x plus 1, and I'm going to put the red equation in. 2x minus 4, and I'm going to do second calculate, go down to the point of intersection. Let my calculator figure out what this point is right there. And it tells me that is the point 2, 0. Then I'm going to use this point and this point and plug them into the distance formula. I can do it on my calculator, or if you do it by hand, remember the distance formula is the difference in the x's squared plus the difference in the y's squared. So in this particular situation, I have 0 minus 2 squared plus 1 minus 0 squared. So I'm going to have 4 plus 1, or the square root of 5, which if you do it on your calculator, you should have gotten approximately 2.24. And that would be the distance between the blue line and the red line. All right, your homework is page 167 through 170. 8 through 22 all, and 24 through 42 even.